Welcome to the second video in the series of where we are introducing the Arduino simulation on Tinkercad. So if you haven't watched the first video in the series, go ahead and take a look at that. I will leave the link to the other video in the description so you can click on it. This video tries to introduce the ability to use analog inputs. Analog inputs are inputs where we can read voltages coming in, and in most devices that's used how to sense outside world, whether it's heat, temperature, speed, whatever the case might be. That's how the computer senses the outside world, is through a proxy, which is the voltage. So in this case, we're gonna start where we left off in the last video, where we had a Arduino board, and then we had connected the power to both sides of this proto board, and had one LED that was connected to pin 2, and it was controlled by pin 2. And then we had written the code in the initialization section, or the setup section. We have set pin 2 to be an output, because pin 2 can be input. All those digital pins on this side can be both input or output, but you have to decide which one by setting this pin mode option here. You can say output or input, and that's what they would do. In this case, we have it as an output, and then in the loop, we have, we turn the pin high to turn on the LED, wait a half a second, turn it off, and do that. And that's what you're seeing is flashing every half a second on, half a second off. Okay. So we're going to stop the simulation, and we're going to try to see if we can use pin A0. Okay. Before we go too far down this path, I want to do some cleanup. Because numbers don't mean anything to humans. So what we usually like to do as we start, we have this ability in the code to define human readable name. For example, we can define the word L pin as being the LED pin, and we can say that the value of that is 2. So basically all this is doing is defining the LED pin. Which one is your LED pin? We're going to reserve another one, and we're going to define another number as a constant, so we can kind of remember it, so it's not hard. And by the way, as a rule, what we use capitalization. If you put two words together, like this is LED pin, L pin, the second letter is the second word is capitalized, so people who read it can kind of read it as if there was a spaces in it, because in variables we do not put spaces. And then we can define another one. Since we are trying to learn analog input, we're going to create another constant. We call it A pin, and that's going to be, we're going to try to use, because these are the analog inputs available on this board. We'll use one of them. You got 6 of them, so I'll use A0 for this purpose, and that would be the we're going to call that one the analog. All right, this is going to be where we're going to connect the potentiometer voltage coming in, the potentiometer sensor pin. Okay, and then we'll come in here, and we still have to say that we no longer have to use pin 2. We can just say L pin, and then we don't get, in a code, when you define a variable, instead of putting a number in, it's a lot easier to keep track of it and make sure there is no, errors happening. Okay. And then for the next set of things we need to be doing is, oh, actually we don't have to do it, but it's good to do these cleanups. Now, the next thing we have to do is come down and do the reading of the potentiometer. So let's see how we do that. So the digital writes are great and all that work. But we can come down and let's say we do the flashing, and after every blink we read what is on the potentiometer. Now we haven't connected anything, so I'll write the code and then we'll go connect it and come back and review this thing. So now we want to basically read the analog input. Okay, and to read that, all you have to do, you had a digital read. So we don't. Let me back up. For the analog input, we don't have to do a mode because it's always an input. It's never an output. So you don't have to do anything up here. All you have to do here to read it is, I'll call it angle because something. So I'm going to have a variable. Variable is where we can store the information we input from the thing. So, but before we can use it, we have to declare the variable. So this is this angle thing I have is going to be a integer. Integer is 1, 2, 3, 4, 5. In this particular case, can go up to, I think this is a 16-bit signed integer, which means it goes to 32,000 maximum. And then you say an integer is angle, it's equal to 0. And so this basically, whatever comes in, it saves and puts it in here. So, and then you can say this is equal to analog read. And it's really important. The capitalization is important. So if you don't have the capitalization, you will have a problem. So what happens is whatever the value is on a pin, it's going to read. But what it's going to do, it's going to basically take the voltage from 0 to 5 volts that comes in, and it's going to translate it into a number from 0 to 1023. Okay? So that's what it's going to do. So it's going to take 0 to 5 volt and turn it into a number because that's all we can save in the memory. Okay? Now I want to see it. I want to see that number as it's coming in. The Arduinos have a very nice feature where they can actually collect the data and send it back through the USB. That's called a serial port. In order for me to use that, first thing I have to do in the setup, I have to set that up. And in order to set it up, I say serial.begin. And then I have to say how fast I want it to go. And for what we are doing, we don't have to go very fast. 9,600 bit per second is good enough. So this basically configures a serial output. So the ability for this thing to send stuff to computer. Okay. And of course, this was setting pin, setting pin as an output. Okay, so we've done those things. Now, all I have to do when I go over here to get this thing to come out is I just have to say, serial dot, serial has to be capitalized. Dot, again, it's very finicky about capitalization, and non-capitalized and sent a word is different than the capitalized word. So you have to do that. And all this, just like this is similar to C programming. So you have to make sure that you have the semicolons at the end of each one of your statement. So hopefully I've done this correctly. So let's put the code away for now. And then clicking on the code puts it away. And then let's go ahead and get a potentiometer. Potentiometer is basically a resistor. That's basically all it is. And what it allows us to do, what I'm going to do, I'm going to rotate it because I want it to be out of the way, but I want to see the pins. And rotation is up here, and as you can see as I click it. Make sure the dots lined up with these things, otherwise it wouldn't work. So what I'm going to do, I'm going to take the pin from A, and I'm going to put it in the middle section. So I'm going to line it up a little bit better. So this ends up just there. Okay, this way I don't have to use any wires. So the center is here, and I'm going to connect one side of this to ground, and it really doesn't matter which. and one side to power. So let me kind of show you what this potentiometer really is. This potentiometer, let's see if I can get a pen here. This potentiometer is really two resistors in the way it works. So you have one resistor and you have another resistor, okay? So the outside pins are the outside of this resistor, and the middle pin is the one that comes out of here in the center. So what happens is that as you put voltage through this, and as you twist this potentiometer one way or the other way, the size of this resistor change. As the sizes change, this is called a voltage divider. So what the voltage is seen in the middle changes. Okay, so that's basically what it is. And it's any kind of dial that you have in your car, in your home, wherever, on any kind of electronic device. If you have a dial on it, most likely that dial at the end is connected to a potentiometer, okay? So this was a bit of a quick description. There are other places that can do a much better job of doing it, but that's all you need to know. And all you need to know is that this is connected to, this is connected to VCC. So let me bring, VCC is another name for plus 5 volts. We use that very common. My apologies for not defining it earlier. And then let's make this a green. Oops. Make it green so it's a little easier to see. Okay. So now we've got this thing connected, and everything is set up, and this thing is running, and so code is here, and then there's a serial monitor here. You can click on it if you want to see what's going on. So notice what is happening as I move the dial. Watch the numbers down here go down. See that? As I move the dial, those numbers decrease. If I go all the way, this gets almost to, it gets to 0. Very good. And if I go way back the other way, it should get up to 1023. So that's kind of the range of this. And what it's doing is as the voltage in here changes, we are reading it in A0 and displaying it. So let's go back to the code and take a look at it. So we previously learned about how to use digital, read, write. Read would be just to replace the write with the read and change the mode to the input, and that's all you have to do. And then analog, read analog input is just a different function call we make. Give it which pin you want to read. In our case is A0, reads it, and then we're printing it. So now we have a way of getting input, and that was the purpose of this, this short video, was to introduce the idea of how you get analog input in and what the voltage gets translated to. So the 0 to 5 volt voltage that comes in, that is the range of this particular device, it gets converted to 0 to 1023. So if you've got a 5 volts, you get 1023. If you got 0, you get 0. And if you're somewhere in the middle, you get that proportional value corresponding to that. And as you can see, you see the numbers changing here. So if you're somewhere in the middle would be somewhere here. So you'll get some sort of 512, 511, somewhere in that range, depending on whether how precisely you position it. All right, that brings us to the end of this video. Thanks for watching.